Hello, so today we will learn about rational expressions and have an introduction on how to simplify them. So what are rational expressions? Rational expressions are the result of a polynomial divided by another polynomial. So we already learned how to divide two polynomials, but here we will learn how to simplify it. So just turning a rational expression with a very complex polynomial as numerator and another one as a denominator, we will see if we can simplify and just reduce that rational expression into something easier to work with, but with a little bit more restrictions, and you will see what I mean later on. But today, as kind of an example and introduction, we will talk about division and how we learned when we were younger how to reduce fractions. So, for example, let's say that we had 12 over 18, and you were asked to simplify this fraction. So what you did is find the common factors of 12 and 18, cancel them out, and leave a simplified fraction. So in this case, for example, 12 can be factored out into 3 times 2 times 2. And the denominator can be simplified factored into 3 times 3 times 2. And here we see that both of them contain at least one 3, and both of them have at least one 2 as a factor, so we can cancel them out. By doing so, we find that 12 over 18 is exactly the same as 2 over 3. And that is how we learned to simplify fractions some years ago. So now we will learn exactly the same, but with variables and having polynomials. So for example, let's say that we had 18a plus 3, and we had 6a plus 1. And we wanted to simplify this. So we would do exactly the same thing we did in the previous example, but now we have variables, but the concept is exactly the same. So what we will do is factor out the top, and you know that you can factor out a3 because 3 is a factor of all the coefficients. But here I'm talking about the numerator. So we know that we can factor out a3, and we're left with 6a plus 1. And then we cannot do anything to the denominator to make it, we cannot factor out anything, so we leave it with 6a plus 1. But see, here we have exactly the same thing we had before. We have two things that are in common, two factors, and we just cancel them out. So in this case, we can cancel out 6a plus 1 and 6a plus 1. And we're left with 3 over 1, or just 3. However, there is a little detail that you must know about this. So, we're claiming that this equation will always give you 3. But there's one case in which this doesn't happen, which is the denominator, when the denominator is equal to 0. Then it's undefined. So let's see why this happens. So if a is equal to negative 1/6, and that was concluded after finding the 0, so let's just work this out. We can subtract 1 from both sides. 6a is equal to negative 1. Divide both sides by 6, and we're we're left with a is equal to negative 1/6, like we said before. So if that was true, then we had 3 times 0 over 0. However, it's impossible, not impossible, but whenever you try to divide something by 0, you get undefined. And so here our expression is actually true only when a is not equal to negative 1/6. So how we represent this? So what we do is say 18a plus 3, I'm sorry, over 6a plus 1 is equal to 3 when a is not equal to negative 1/6. And that is our simplification of our rational expression that we had before, right here. And so we'll see a little bit harder examples and work them out, but this is the basic idea, and all can be related back to this very simple example that you know exactly how to do.